more about geospatial. And currently, actually, I am co-supervising 2 students from the Faculty of Science for their FYP first year program with Dr. Alin in ISB. So basically, what I found out that this geospatial technology can be used across borders, across subjects, across faculties, and of course, it can be used, but not necessarily you understand what you are dealing with. So it's very, very important for us to understand about the concept of geospatial before we start doing things and start collecting things for your competition. So may I share the screen, Prof?
Yes, go ahead, please.
Thank you, Prof. Okay, so for today, I would like to actually give a little bit of explanation on, like a little bit of small lecture, small explanation on the GIS especially, and what are the tools that you can use in this competition, as well as how to get the data, how to obtain the free data sets from the internet. I would like to off these subtitle. It's really, really disturbing. Okay, so my name is Dr. Nish. People call me of the name Dr. Nish in Actually, my name is quite long, and that's my email. If you would like to ask me any questions later, you can email me. We will look at the table of content today. So I will only touch a little bit on what is geospatial data and data in spatial science. What is the heart of spatial data? Spatial data on various sources, web-based spatial data, OpenStreetMap, Esri Living Atlas, Google Map, OpenStreetMap for the other link, QGIS plugin, and also some of these maps produced by some of our students who took cartography in the Department of Geography. And the Department of Geography, we have one course actually for map making. The name of the course is cartography, whereby we learn from the projection, how to create the data from zero to producing a maps. But I believe in this competition, you have a very limited time, and I will show you on how to get this data without having to produce a data from by yourself. I mean, like you can find the data on the web for your competition. All right. So when we talk about geospatial data, previously people always refer it to GIS, Geographical Information System. At that time, a term of GIS is only a term for GIS itself. But because of now, we are combining a lot of things into GIS, basically including of the data set, including the way of how we took the data, using drone technologies, using remote sensing, using handheld data capture, using even vehicle such as Google Photos and something like that. So GIS cannot cover this term anymore. So now we use the term is geospatial data. Whereas this geospatial data not only covers this data related to Earth, but also anything contains in it, including an attribute, our names, our coordinates, the characteristic, the phenomena. Okay, so of course, when Prof. Siti told me that Dr. Nish would like to be in this program, I'm so delighted because it is a cross-boundary. And of course, Faculty of Science use a lot of geospatial data, especially in ISB, whereby you look at the landfill setting and something like that, and also in bencana or disaster. So it is used across the board. And we are quite okay because the data set is actually free for use from the satellite imagery. And we can also provide data sets from multispectrum that is, you can see the vegetation growth and problems of the Earth. You can solve it using the satellite imageries. That is also free for us, yeah? So basically, the data in the spatial science, they have like several kind of things, yeah? First, before you do anything, before you want to take on this competition, you need to understand the data. The data is very necessary. Of course, your topic is very necessary for you to know what kind of data you need. And then how are you going to collect your data? How are you going to expose your data? And particularly how you want to integrate your data. All right. So spatial data are used to represent variables and their interaction. For instance, you want to see about the change that happens in Faculty of Science through time. So you will need to have all data sets, all image from the satellite maybe, and the current data sets from the Google Earth map or something like that to do the comparison and a lot of things. But one of the important things that I want to focus on is the spatial data set itself must have a coordinate. And although we take these data sets from various sources, we have to make sure these coordinates are in same projection so that our data can be displayed together. So if we have different projections, we have maybe we want to use the longitude and latitude, WGS 1984, or you want to use MRSO. So when you combine the data set, or even if you use Cassini, if you combine the data sets will not talk to each other. So you cannot see these layers together because they are in different projections. Okay, so what else? So I believe that maybe some of us already have the data, observational data, imageries, visual image, and maybe some of the experiment, numerical measures and variables. All this can be inserted to the GIS and represented in the maps, right? So I think this is a very historical map, Prof, from 1974 in our collection. Can anyone spot where is the Faculty of Science? Okay, this is the library.
Upper left.
Yes, Prof, it's on the upper left. Okay, this is on the upper left. This is our lake previously, and this is the setup of our university in 1974. So not much change, I think, because our campus is sustainable. We keep on what we have, and we do not overdevelop what we have. All right, so this also can be used as if you want to see the change, if you want to see how we have progresses over years using old data sets and new data sets, right? So we have a lot of this in the Department of Geography, and the heart of spatial data is maps. Existing maps, topography maps, land use maps, roads, water network, and populations data. So when you talk about maps, actually, we can get additional data of what we have now. Okay, maps is not imageries. What I show you this just now is image. This is an image. This is not a map. So there is a difference between map and imageries. Yeah. So basically, of course, when we talk, we look at this map produced by Jabatan Ukur dan Pemetaan Malaysia in 1974. It has already a scale. So, and also coordinate. If you pin this coordinate correctly, you can overlay this image with our current Google Maps, for instance, for analysis and so on and so forth. Okay, so spatial data on various sources. So all these are spatial data sources, especially we have a lot of topo maps in in our department in geography. This is a satellite image from Google Maps, and also this is the OSM. It is very, very easy to use OSM and get the data sets done. It's free. I will show you how, right? Okay, so basically, the web-based spatial data is free for use, but you have to know how to use it. You have to have an open source data API and many others, and it can be retrieved on the go. All right, you don't have to use maps anymore. You have the sharing capability of the data and also manipulate it using the open source software. Okay, so firstly, I would like to introduce about the OpenStreetMap. Okay, this is a collaborative project to create a free editable map of the world. The geodata underlying the map is considered the primary output of the project. We will see how the OpenStreetMap is open in the GIS software later. And this is also the source of data from Esri Living Atlas. This map or this data can be downloaded and can be put into your GIS software for further analytics. And because there is a lot of data in cloud currently, And these products such as Google Maps, Google Satellite Hybrid, Google Terrain, Google Roads also can be put inside the GIS software using this URL link. Okay, all right. I have also attached the link and how to do it here. I will share these slides to everyone later. So you can open this website to know how, maybe if you need it later. Okay, so step 1, you have to register the OpenStreetMap. And step 2, you have to manipulate, get info, and download your data sets. And our software is QGIS. QGIS software is a free and open source cross-platform desktop GIS and also remote sensing. It has the capability to display, manipulate, analyze the GIS data sets, and also used widely for public and private companies for GIS analytics. It can be shared. The data can be shared with ArcGIS easily across platforms. Yeah? So we can share the data, we can copy the data into the Esri platform. And of course, normally what we do is we use GIS for all the data collection and everything. But for the further analytics, you need specific software like ArcGIS. You will transport all these data sets into ArcGIS. Okay, so this is also an example of the Quick OSM plugin. I will show you how to do it later. And after this, we have the demo using QGIS and OSM. All right, so this is some of the maps produced by our students. The implementation of e-bike path in Bandar Beraf is one. So basically, we can also produce something like this in our maps for this visual competition, right? So basically, some of the database, some of these are drawn by the students. I think this is actually drawn by the student itself. They digitize it from the maps and put some information, some legend, okay? Yeah, right? So that can give you some ideas. There's also some more project by one of the students. I think this is one of the best, okay? And she cleverly rotate that Sabah and Sarawak into another position. Okay, in cartography, there is no right or wrong on putting the maps. As long as the scale is okay, and you already have an inset here showing the exact location of this map, but because you want to fit it in one, you rotate it into a certain degree so that you can show in one map. But again, maps are not to scale. It's not to scale. If it is to scale, Sabah Sarawak, Semenanjung is actually bigger than Sabah Sarawak now. Okay, but it's not that case, yeah? So this is the way how we produce the visual GIS for us to maybe show something that we want to show. Okay, you can manipulate the data. You can show the data into the real inset, but inside here you can manipulate. Okay, and this is another one. This is also, for me, is quite very, very well done, very well. So this is a key plan or inset, the legend and big cities, airport, and so on and so forth. This is also, some of it is digitized by the student, but some of it are obtained from that free data sets that I showed you previously. Okay, this is a simple one. If you want to do this, you want to put some pictures here with additional location days, you can do that. It's not that hard, it's quite simple. Okay, and something like this also, Pulau Besar Melaka with all the petunjuk, all the legend, and also some spots to show the maps. Okay, Langkawi. All right, so that are all the examples that I have for you to show you. Okay, you have any question at the moment? You want to ask me any question related to what I have actually spoken about? Any question for now? No?
No, Doctor.
Okay, so
Dr. Nis, just a quick question. How do we see the Google Earth in this context? The one that we have a satellite picture. And will you discuss about that?
Yes, I will show you. I will show the student how to put it on. I mean, like I will use the QGIS, and we will open that link, the OpenStreetMap and everything, so that the student can see that all this map can be attached on one another. And also, I will show them how to extract the data sets from OSM. so they can use the data.
Thank you.
Okay, I will proceed with the demo now because we don't have any question. Okay. So this is the link. Okay, if you want to know more about the open source, is here. Okay, the one that I took, Google Maps and everything is here actually. And let's look at the QGIS. Okay. All right. So this is QGIS, freeware, open source software. Can you see my? Oh, I'm not sharing that one, is it? Oh.
We can see the QGIS website.
Oh, okay. Then you can see
the program window. We can see that.
Okay, you can see the program window. Okay, because I'm having two screens. It's really confusing for me. All right. Okay. So this is the QGIS. I think everyone can install this. You can find it in Google and install this. Any version will do. Okay. So this is the Google Earth Maps, Prof. Like what you say, in the QGIS. So basically, it's already embedded in QGIS. But if you have just installed QGIS, these are not here. It is empty. Nothing is here. You cannot get this if you just install your software. You need to put it in. Okay. The next example is the OpenStreetMap. Okay, this is the OpenStreetMap. If you want to see the different okay, that is overlaid of Google Maps on OpenStreetMaps, right? So I will have another one. So for this one is the OSM landscape, whereby it has the 3D areas displayed, but this one acquired API key required. I don't install it yet. Okay, and Google Satellite. So this is the Google Satellite inside the QGIS. So basically how we do this is, okay, inside the browser, there is one area. It's called the XYZ tiles. Okay. At this XYZ tiles, actually, we need to put in the database. We need to link in the database. Okay, I will remove first the Google Satellite. Edit. I will remove first. Okay. Okay, I will edit. Okay. So I want to add a new one. I just click at the XYZ tiles. Create add new connection. And this new connection will come out. And we give the name. Okay, and we paste the link. Is the link that previously I showed on the table, yeah, in the table. So just click OK. And it's here now, because I removed it just now. So I remove it here. Okay. And when you click, it's automatically it's here lah. Basically. Okay. So same with all of this. We need to do that. We need to add the layers in new connection. Okay, and I put that the connection side inside the presentation. But I think the OSM, OpenStreetMap, okay, OpenStreetMap is a little bit different. The link is different. I will share later. I can also share in the chat. So you can actually, okay, OSM link, yeah, link to QGIS. Okay, right. So you just put that inside your QGIS, and automatically the OSM is available to be used. Okay, so this is only displaying the data. You need to digitize these data sets if you want to use it. But how are we going to use the data that is available online? If you don't want to digitize, if you don't have time to digitize, what we need to do is we will go to the OSM itself. Okay, hold on. Is my having two screens is actually very, very okay. All right. So for instance, yeah, Prof, this is a Living Atlas at ArcGIS website. This data here also can be downloaded. Okay. So for instance, I want to download the land cover. I just click download land cover. Okay. So it will come out like this. So we have to choose which land cover you want. So for instance, I just take someone somewhere here in the year 2022, maybe. Okay. And now it has been downloaded. Okay, so we take another one. Okay, we wait for the data set to be downloaded for a while. Maybe it took some time. Okay, never mind. I will show you some data that I have actually downloaded previously. So that is the way how to download it. Okay, I will add data. Okay, hold on. Okay, I show you one data set, yeah, Prof. So basically, these data sets that I show you here is actually downloaded from the USGS. Okay, USGS satellite. It is free to be used and can be analyzed. But if you want to use this, you have to actually use the remote sensing software. You have to stack it. You can stack it in the QGIS. And if you want to analyze it, you can also analyze it in the QGIS using NDVI. Maybe you want to look at the NDVI and something like that. Okay, so this is the analyzed imagery for the NDVI. NDVI is actually for us to know where is the vegetation cover and non-vegetation cover. You can actually map it using several colors to see the multi-band color. Hill shade, actually hill shade is better. Okay. Right. Okay, so we can actually put the color, but I have to set the junks here for us to see the different color code. Yeah. This is one example that we can use the data sets that is available for us free of charge lah. No payment needed. And just now that we have download. Okay, this is the data that we have downloaded just now. Okay. From the Esri Living Lab. Okay. Zoom to layer. Okay, this is the data that we download just now from Esri. So this is also can be used, ready for use. And you can explore more for this data set. If you want to change the codes, if you know the codes, you can change it, maybe land use, maybe vegetation, urban areas, water body, and so on and so forth. So you need to know what is the code to change it by the legend. Okay, this is an example. All right, there's another example of what we can actually get from the Google Earth Pro. Okay. This is very, very new. I just actually got to know about this. So for instance, this is area. I wanted to see the shed. Okay. Placement is too low. Okay, just automatically. And then you can see actually they're more like a 3D areas of So with this information, actually, this is the new information that I got, that now I know that actually is in a lowland, Prof. And why we actually have a lot of flood recently because of this urbanization and everything. And we are actually at the lowland of the Klang Valley, the Lembah Pantai area. This is also can be used for your study in this competition. So you make your topic, choose your topic, choose what you want to do using all this data set. Is freely available for everyone. And it is very, very interesting to know that everyone actually can get this data to use it for your own topic that you choose lah, basically, right? And yeah, just cancel it lah. Okay, lama sangat, too long for us to see it, right? QGIS, okay. Okay, OSM. Now I want to show you how to take data from the OSM. Okay, yeah. OSM.
Sorry,
Yeah.
Doctor. Just
Yeah.
now, which database you get it?
The database?
Yeah,
I
just
got
now the
I
one
got
that
from
you
the,
say is a very new one.
Oh, actually, it's in the Google Earth Pro.
Google Earth Pro. Okay, thank you.
Google Earth Pro with shadings. So if you use your Google Earth in your desktop without having install the Google Earth Pro, you cannot do that. You have to actually download the Google Earth Pro for you to do that.
Okay, thank you. Thank you.
All right. Okay. And the OpenStreetMap, the OSM. Okay. This is the OSM, OpenStreetMap. They have their own website. So the one that I show you just now is how to open this website into your QGIS. But if you want to get a data sets from OSM, you have to log in. You have to choose your area. Okay, for instance, I choose this area. Then what I do is I export this data. So when I export this data, okay, all right. Manually selected different area, yeah. So this is the area that they actually we are free to download. Actually, very, very small, not so big lah. But I think it's okay for UM utilities you want to use for UM study. You can use this. So this is the area we want to export. You see that when I take a bigger area, I cannot export. But if I choose a smaller area, then I can export something like that. Okay. So we export it. Okay. Too many nodes, yeah? Too many nodes, meaning that we have to use smaller area. So I will use the smaller area. Manually select a different area. Something like this, small area. Okay, and export it. Oh, actually, previously I can. I don't know why they are restricted with very, very small. Okay, maybe we just take the Pulau Dayang Bunting lah, just to show you the area, yeah. Okay, so now it's exporting the map1 OSM. Show in folder. So it's in there. Okay. Open QGIS. Just drag it. Just drag it here. Select all. Okay. So now that you see, the map is already there. Easy? Yes, okay. So this is the way you get the data. You don't have to actually digitize anything. You get the data freely from the website, yeah? Of course, you have a limited area that you can download, but this is very, very helpful because you don't have to digitize each and everything. You want to find a map and digitize everything is going to take some time for you. Get it from the OSM, but you have to register yourself to get the data, yeah? All right. Okay. Any question at this moment?
Dr. Nis, is there a limit for the resolution? Resolution of the map, you know, how detailed you can go before the data, become breaks down. Because we are looking at a small area of the science complex.
Yeah.
Okay, so in that context, yeah.
Yeah, let's go and try to download Faculty of Science Complex, yeah, Prof? Okay, kita pilih Universiti Malaya.
Okay, one question. Yes,
yes.
For the competition, do we have to standardize this Faculty of Science area to do the task? That means it's like we have the scope from this map for the Faculty of Science area, and then we use the same map or something like that.
For that question, I will answer this. The focus of this competition is for Faculty of Science. So when you see the image put up on the poster, is basically what we call the science complex. So the focus is that image, but it can capture roughly the area, but you can go a bit more, a bit less. That depends on, but it's not to say we can go to other faculty. This is sponsored by Faculty of Science. So the ultimate aim is to get a GIS, geospatial data for Faculty of Science. So the winning entry will be the referral for Faculty of Science in their coordinations, in their orienteering, plus the information. So we are doing it as a part of competition to get the best that will be taken up by Faculty of Science. So your winning contribution will be there as part of the the science informatics. Yeah.
Okay, all right. We will get the some sort of original info for the area for the Faculty of Science, and then a little bit more or less is okay. Thank you.
Okay, this is the Faculty of Science, Prof, and everyone. Okay, so we just zoom to the group of layer, and this is the faculty faculty and plus some more else here. Okay, so map multi-polygons. Okay, we go for the properties. From these properties, actually, we can use categorized area, buildings maybe, or you want to use a graduated color. Or what are the values inside the data. So the data has a lot of information actually. For instance, we use the categorize, okay, and let's say we gonna go for building, classify, apply, then we get this information already. Of course, when we talk about Faculty of Science, you may need to add more data sets to this. You may need to label all of this. You may need to produce a database for this Faculty of Science. And how about all this information that is not related to Faculty of Science? You can delete it. Yeah, you can delete it, not a problem. Okay, so for instance, some of this building, you click on this building and then you have to create a database for this building. In creating the database, before we can create a database, this data that I show you here is actually not yet a GIS data. It's only a representation of OSM maps. You need to convert it into a GIS format data. So you need to convert one by one. Convert one by one, maps to lines. Okay, we have to export it into a feature. Save feature as. Okay, save feature as ataupun kita boleh select all. Okay. Export to save feature as. Shapefile. Ini file name, you masukkan dia punya file name. Okay. Okay, kita buat satu-satu lah, one by one ya. So I not confuse you. Okay. Just use one by one. Maybe we take the first one is the map multi-polygon. Export it. Save feature as. Look at here, it's Esri shapefile. That's why I told you that if you use QGIS, it also is compatible with Esri, no problem. So if you want to use Esri for manipulation and that data manipulation, also you can do that. So we put the name is polygon maybe FS, yeah. Where you want to save it? Save in D. Okay, save, right? Okay, remember that I told you about the projection. This is the projection. So make sure that we are using the same projection here. If you use many data sets, make sure this projection is the same for every data set. So if not, it's going to give you a problem because there's a lot more. You want to use zone 47? If you want to use zone 47, you can choose zone 47. If you want to use Kertau, then you use Kertau. So you have to standardize. Okay, so this you have to standardize. Choose maybe the easiest one is WGS 1984 because this is the longitude and latitude location of the area. Yeah. Okay, so click WGS 1984. Okay, and just click OK. Maybe we save that to map. Okay, so now it's already saved. When it's saved, it's going to duplicate your screen. So now you can remove that multi-polygons, this map to multi-polygons, you can remove it. Remove layer. Okay. You open the polygon faculty science properties. You make it a graduated or categorized field. What are the values you want to see? Maybe the name, maybe a boundary, maybe you choose whatever you want. I choose a building. I classify and I apply it. Okay. Yes, something like that. And for every lines, also you need to remove. You need to save it. If you don't save, the objects there, it's not going to be displayed later if you open your project. Okay, now we save the second one, map to multi-strings. Same, export. What is map to multi-string? The name is very confusing. You have to check. What is it? Map to multi-string. Maybe you need to off first your maps and look at, oh, this is maybe the road. You rename it with a name that is reflecting the objects on the screen. Don't name it with something else, yeah? So we export it, save the feature as. Okay. Same, where you want to save it. It will go back to, I don't know where, but you have to find your folder before you save this data set. So I normally use a different folder D because it's easier for me to find it later. Okay. Road maps. Okay. All right. So it's also showing on the map. Now you can remove this one. You can remove this one. So if not, you'll be confusing. Okay. But don't worry, you have already saved it as the not safe. Why is not safe? Okay. If it's not safe, you have to take back your OSM map and bring it here again. Okay, you select maybe multi-line string number 2 only. Okay. And click OK. Okay. So this is not the road. Okay, we have to take it back. So this is happening. So make sure that you save the correct one. Okay, save the correct one so that you can have the correct data stored and saved with the correct name. So I will remove, okay, so map 2 lines. So this one, yeah? This one, yeah, as a road. Okay, save it, export. Okay. Override file. Okay, just give it a different name. Okay. So now it's already saved as the Faculty Science roads, yeah? And now, next, what's next? What is this? We have to check it. Map multi-filter. What is map multi-filter? So there's a lot of editing work that you need to do. You have to clean, you have to make sure what you see, what you want to be on the map. So basically what you need is only some part of these areas. Okay, and remove everything. I want to look at what is the second map to multi-string. Maybe there's nothing there. Yes, there's nothing there. So you need to just remove it. Remove layer. Okay. Okay, this is the points. So basically, click at the properties. Okay, we click at the properties. Symbology. Attributes. So what's the symbology? Where does it come out? Diagrams. Okay, symbology should actually come out like this, yeah? So that we want to use the symbol. Okay, but for you need to export first. Forgot. Okay, so now choose any area to export. Okay, POI, UM. Okay, point of interest. Save it and click OK. So now there is a POI here, and when you click the properties, you can see this markers. You want to maybe categorize it with the values, maybe the name. Okay, and you click labels, single labels, apply. Okay, better that we off this polygon for us to see. It's not saving. So now we click to the properties and then we click single labels. So you have to know what is inside here lah, for you to choose basically. So you look at the database properties. Maybe we just use the name lah. Okay, right. And on the map, okay. And you have to make it beautiful by changing the location, making the text better and everything like that. So this is just a basic kind of manipulation of the data that you can do. What else? So if you want to look at the database, you open the attribute table. So now you can see there, these are the database, yeah. These are the database. These are the location, point location, okay, point location plus the location itself. So let's say for the buildings, okay, we try and look at the buildings just now. POI, okay, properties. Can we actually choose the building? There's no information about the building, only name, and maybe we can also put the label. Okay, and remove the POI information. Properties, put one label, key name, apply. So it gives you information of all the buildings already. So you don't have to go and find out. It's already there. But it's up to you how you want to design it, what kind of data you want to put, what kind of image you want to associate it with. Maybe you want to associate it only in, maybe you want to choose only one department, ISB perhaps, and then you can create that information with pictorial information when you design the maps. Any question at this moment?
Hi, doctor. Can you hear me?
Yes, yes.
Yeah, I'm Jun. I have a question. Among all of this database that we are able to get open source, is there any that is able to provide us like a 3D image?
3D model?
Sorry, 3D modeling of it.
Yeah. Actually, there's a lot of open sources data with 3D model, and some of the data is actually not an open source, but it's actually from the satellite. But you need to have a capability to analyze that satellite data before you can add in. And maybe one of your team members have the capability to actually download and analyze the satellite data, then you can use it also.
Oh, I see. Would you recommend any where that I can start looking for this?
Okay, maybe you can go to find something like free DEM data.
Can you repeat free
DEM? DEM is actually digital elevation model. So if you have a 3D data, you want to put the elevation model, okay, so you can get a lot of from geography sites. So you can download it, 10-meter DEM download and something like that. Of course, you can also get it from the YouTube, how to do it, okay? Spatial resolution. And also sometimes when you go to Pleiades website for the satellite, you can also get data from that. So we have to find, sometimes with Pleiades, maybe selected areas is available for download, some areas are not available for download and something like that. So there's a lot of advertisement lah, of course lah, yeah. Okay, so link, okay, download radar sentinel image link. There's a ASA link. There's a lot of links here. You can try. Okay, but I actually didn't prepare for you the the 3D model, yeah, of course you have to register and get access. Just try to put in Universiti Malaya. It asks you to have the access login. So you have to log in. You have to log into some of the sites. That's why I actually choose only a few for you to get your data. But there's a lot more on the internet you can find. And yeah, there's a YouTube also on how to get the data. And normally registration is not so hard, very, very easy. As long as you tell them who you are and then give them your email, it can be done, not a problem. Sama juga, same with these OSM data sets, you have to also log in to your accounts, but you don't have to pay anything. They just want to know who downloaded the data. They want to record who downloaded the data with a credential. That's all. Okay, Mingjun?
Right. Yeah, thank you so much.
Right. And USGS, Earth Explorer. This one is a higher level. But of course, USGS Earth Explorer is actually giving us data 30 meters resolution. 30 meters resolution means that 1 pixel is 30 meters, is very, very big and broad. And if you talk about Faculty of Science, you just get a small data set. So I don't actually recommend you to use USGS because FS is very limited. The area is very limited. So we only have a small pixels in that image. But if you want to look at the change of our university since 1970s until now, you can do that using this USGS data sets because they have data since 1977, but only thing you have to find in the database, that's all. Okay, so for instance, I just log in. Okay, sign in. Okay, so we use a geocoding method. Okay, Kuala Lumpur. So basically, all our places in Malaysia mostly is can be searched by this software lah. Not really hard for us to find KL or Malaysia inside the maps. Okay, so they don't find Malaysia. We have to go Malaysia. Sure. Okay, so this is the location of KL. You click to that, so you can see that there is a location here for Kuala Lumpur already. So we are basically in KL, kan? All right, so if you want to look at this, also you can, so you find the date from maybe 1990. Okay, just choose any date and then the end date will be 2023. Just choose one date and data sets. You have to choose the data sets here. Digital elevation also, they have it here. Yeah, if you are lucky, then you can get it here for the DEM, the 3D model. So basically we are looking at Landsat. This data is actually Landsat. You have to look at the Landsat legacy because we want the data to be the past, the historical data. Look at the years. And just now we see we want the 1990. So 1990 is basically the ETM PAN 1990 until 2003. And we also want Landsat collection for 9. Okay. Okay, all right. So this is not usable because there's a lot of imageries. Okay, a lot of cloud covering our area. So we choose something that is clear for us to see the location. Okay, so we do this. We put the footprint. This is the footprint, and we put the image on top. Okay, so it is clear, yeah? This data is in 2017. One image in 2017. So of course, you see, it's very, very small. If you look at this point of view, it's very, very small. It's almost the same like you use this Esri Sentinel data. Almost the same. Almost the same, yes? Okay, so let's say you go for this Earth Explorer and then you find another date. This one is 2004, but it's also cloudy. Next. So this one is 2022, sorry. Next. So the last, we go to the last one. The oldest one that we have in record is in 2013. But actually we can get more. If we add more additional information, additional image, then you can actually get more. So basically, because we select only 2, there is very limited, and some of the image is actually covered by cloud. So for remote sensing datasets, you can use it, but the resolution is very, very low. So maybe not suitable for this kind of approach in this GIS competition. Okay, right? Any more question?
Hello, doctor. Can you hear me?
Yeah.
I want to ask, is it more suitable to use QGIS than ArcGIS? Because I have ArcGIS.
It's actually okay with ArcGIS. Okay. The trick here is because QGIS, they don't link. There is a link. QGIS, if you have the ArcGIS Pro, they have the link with a lot of database, a lot of images database. So we can use it also. Okay. You don't need to use this kind of links because it's already embedded. But if you don't have that to your ArcGIS, if your ArcGIS is old version, then you don't have that database link inside your ArcGIS. You use QGIS first, get your data, download your data, make it a shape file, so you transport it inside your ArcGIS for analytics. Then it's easier for you.
Also, what I'm understanding is ArcGIS is for analytics rather than the mapping, or
yeah, it can be used for mapping.
Okay.
Because Prof Siti asked me to use something that is open source, so everyone can use it. You don't have to pay for it. That's why I use QGIS for actually mapping with QGIS is a little bit easier than using ArcGIS. But of course, in terms of analytics, ArcGIS is powerful.
Okay, I understand. Thank you.
Welcome. Okay, any more questions?
So Denise, I just have a general question. The theme of this competition is GIS visual science. Okay.
Okay.
So apart from the mapping and on the geospatial information, ultimately we would like to have that map actually comes alive.
Okay.
So in that context, there can be any form of maps, even the maps that you're showing now, and compared to a satellite map may looks real, but you can also make a story comes alive in this map, the current map, polygon map, right? In this QGIS. So now in this competition, we didn't set what should be the platform that you must use, what kind of map that you must produce. So in your example that you showed earlier, you showed a variety of maps, right?
Yes.
But then exactly that's what we are expecting also in this competition. So the participants may also, will be a little bit, comforted that you can have many types of visual representation of the data on a map.
Indeed.
So those people who works in the area of GIS, maybe they want to use the more professional representation.
Yeah.
So I think there is a lot to tell from your map. That's the tagline for this competition. So you can bring that story alive with annotations, how you have augmented the data on this map, you can still stand out. All right. So bringing the professional, geospatial data mapping plus story, then it's a winner. But of course, you can always, surprise the panel with the story map.
Yes, of course.
So I hope this is comforting to people who are not familiar in GIS. But we want to at least, be aware that data, maps, cartography, all these are exciting representation of the earth and the people. Yeah.
Yeah. And of course, I think that for instance, this map, the Rawa Island Johor map. Actually, this student she have no idea what to do. She told me she don't know what to do. I say, you think of one place that you have close in your heart. So she said that I like Pulau Rawa Island Johor. So you produce a map for Pulau Rawa with additional info on these visible things that you like there. So basically, so if you can see here, there are scuba Rawa, cactus garden, that are interesting places there. And it is put on the map to show as a additional visible visual representation of that area. If this is only a point, you put the name hilltop view, people don't know what is hilltop view, where is it located, and how does it look from the top. But I think this girl, actually, she's quite clever by putting on these images to show the exact location of each of the area. And yeah, like Prof say, don't be surprised by anyone. You can produce your own maps and you can have your own creativity basically using the GIS. GIS is just only the tool, but you come out with your creativity in creating. Maybe you just only want to choose one ISB and then you want to have I don't know, images of each of the area there and something like that. Or the whole area of a Faculty of Science, and then maybe the direction like this, showing that, oh, from some area, some places to actually Faculty of Science is a direction with distance and something like that. So these are the things that can give additional information, but not only about the maps itself. And one more thing, if you are producing a map, there are several what we call a guidelines to produce a map. Firstly, you must have a title. Okay, and you must have your legend. Must have your north arrow, scale, of course the body, okay, and insert, who did it, okay, and a date of publishing it. One of the important thing is actually the frame or this border. This border is actually give you a little kind of nice kind of closure of your map, and you can create this, okay, and put it on your map. Who created it, using what, and so on. So you arrange it on your own. You have a key plan. Of course, Prof said, oh, we want only to show you the map of Faculty of Science, but UM is so big. You can map. You put the map of UM here, and where is actually Faculty of Science located? Maybe, perhaps, yeah. And what are the things that is there? That important thing, that interesting thing, point of interest in Faculty of Science. You have cafe, you have libraries, you can map it there. Tourist spot, you have to create a title of objects that you want to show. Roads, maybe some of here is culinary, tourist spot. So you have a attribute data. Okay, so the attribute data is inside the QGIS is over here. So let's say we open this attribute table, mana? Okay.
Dr. Nis, we did mention at least 3 attributes. That's the idea, at least 3. But, it's not necessary also to go very large number of attributes until the image becomes too crowded. So it is just like sufficient amount of attribute to bring the story, clearer and to link that to any one of or combination of SDGs. So as you said, you know, the map as a title, the title reflects the theme. The theme is the SDG thing, and SDG focus on a few attributes. And hopefully many different submissions will cover different attributes. When we merge data at our level, then it becomes fuller and more, you know, combined information. Yes, thank you.
Big data, indeed, Prof. That's correct. Okay, all right. So I think Prof is actually explaining a very, very good point. Of course, you have a limited focus, Faculty of Science, whereas what I have shown you in the slides is actually having a lot more. Not only that, you can do anything you want, but of course you can be more creative in putting it on the story, like Prof said, the story of the map itself that you wanted to show. Okay.
I got a question. Just now you say we can add image. I see sometimes they put the 3D over there. How do we put that, the 3D?
Okay, so basically this data set is actually obtained from other website, free data as well. So you download it, and then you just, if it have the same coordinate system, it will be overlaid on your data. So actually this data set is actually get from the forest cover data sets from satellite. Free data also. Free data set. So you have to find it. Yeah.
Okay. What I mean is like for example, if we want to view the ISB building, right? You can show the image of the ISB building, but instead I want to show the 3D building. Do we have to do something more or how?
Understand. Okay, understand. So if you the data sets for building 3D is actually not free lah. Not free, and whether that data has been collected by I'm not sure. Maybe Prof Siti can give you a little bit insight of that. Normally a building, three-dimensional building is taken using drone data. That's called LiDAR, laser detection and ranging. So that is actually saved in the database, a different database, but you can display on QGIS, because in QGIS also you can also display 3D. But we don't have the data. I believe that also don't have the 3D data for Faculty of Science.
Okay, thank you.
I suppose that would be quite ambitious time as well. To create a map. On top of that, you have buildings, 3D recon. So that requires more work, and within the time limit of this competition, I think that's the part for a competition. One must realize how much time you have, what are the things necessary, sufficient to meet that target. Yeah, if members of the team has expertise, you can stretch your imagination, as far as the capability and also the facility that we have. Yeah.
And okay, if you have the Google Earth Pro, okay, maybe I can show you something now out of this. Maybe you like 3D, so we can look on how we can actually see a 3D model. Okay. We have a lot of layers, so I need to off everything. So if I have terrain, this is a terrain, meaning that you can see there's a little bit 3D. This is Google Earth Pro, yeah? You have to install a Google Earth Pro to do this. Okay. So this is what we do when we show a view shed. We can actually see a three-dimensional areas of the area in okay, where the lowest area and something like that. But of course, if you want to take your own 3D data, okay, what you need to do is you can, where is Faculty of Science? Oh, here. Okay, this is a Faculty of Science. Okay, so if you look at down here, there's an elevation here, 0. I am not sure whether this faculty have a different elevation. So you see, this is elevation down here, 0 meter, meaning that we are at the same level of the mean sea level. So that's why we are actually at a lowland. But if you look at block C, a lot of things. So maknanya dia nampak macam serabut sikit. Sekejap ya, I tutup semua dulu. Cover everything first. Okay. Okay, so basically in UM, the area is actually flat now. There's no height information here. So if you want to do a 3D model, let's go somewhere else. Why it's not moving? Huh? Google Earth. I think it's not right. Okay. All right, so Rumah Universiti Malaya Sari. Yeah. Where is the library? Okay, here kan Prof, Faculty of Science. Okay, so tengok kat bawah, look down here, the elevation is actually 0. If you want to do a 3D model of UM, it's actually, there's no model, no 3D model of UM. But I'm not sure whether it's correct or not. I will look at, so let's see. Kadang-kadang Google Earth ni pening juga, Prof. Dia... Yeah. Let's measure. So kita tengok dekat Faculty Science saja ya. Science. Loss orientation. Okay, here. So we do this measurement. Part. Okay, maybe from here to here. Okay, so the maximum elevation is 36 meters. The lowest is actually the higher point is 47 meter. The lowest point is 36 meters for this area. So where's our bukit in Faculty of Science too?
Bukit merah tu itu APM.
Hah?
Yang merah ke atas tu actually APM, itu atas bukit lah, APM.
Oh, yang ni, yang merah ni.
Itu APM, itulah bukit.
Okay, so kita try to look at the elevation, comparison of elevation. Betul lah, Prof. It's actually 60 meter on the top, and then bawah is actually 40 meter at this area. So basically, that not much of 3D model that we can model from our data lah in UM. Tapi sepatutnya bila kita klik dekat one area, dia akan terus keluar dia berapa tinggi. Something wrong with this Google. Google elevation ni. Should be putting on here, down here, should give us an elevation actually. But it's not giving. So something is not right. Okay, let's say you want to collect all that elevation. You have to do point by points lah. Okay, points by points in areas. But is it important or is it not? It's up to you to decide what you want to do. Okay. You want to map the shades. Okay, Prof, there's one more important or interesting thing that I want to show. Sebenarnya, when we look at this this one, okay, we found out actually Universiti Malaya consists of a very low trees, Prof. From this satellite imagery and juga apa kita punya ni lah. So very limited numbers of trees. So these are the analytics yang kita juga boleh buat lah. We can do this also if you want to do that. Okay. Rangeland adalah sikit-sikit. But of course, if you look at generally as the whole of uni and the whole of area, okay, when we go bigger, the coverage is much more higher. Okay, and that is important for us to actually save all these forests near to our city, because it's actually being the pocket of forest for us, taking care for our city sebenarnya. Yeah, so maybe you want to explain, you have one big areas and one small areas and do some comparison and showing that the importance of Universiti Malaya as education center and also the surrounding areas yang outside the pocket of the city is actually controlling or complementing the SDG, something like that pun, it's up to you. It's no limitation. But limitation is the sky, Prof. Sky is your limits lah.
Exactly. And the imagination, stretch the imagination.
Yes,
you pointed out a lot of things, different, like the Sentinel data showed the campus, the green footprint, and the universities often, stress on the ranking on the SDG ranking. But we should have evidence-based justification whether this is shrinking or increasing, right? So this project, some of the participants should raise up this as a part of evidence-based data, and then we take effort to reverse that, if it's a deterioration, we take effort to reverse and to promote a green patch in the campus. Yeah.
Betul. Okay, so basically kalau kita tengok, our campus does not change. And I went to MGTC yesterday to meet with one of the carbon credit punya person there. Miss Alina, she's from MGTC. She's from UM. She is from Faculty of Science. And now she is leading MGTC, one of the biggest role there lah. And she said that Universiti Malaya is actually very sustainable in a way. And we also win the sustainable low carbon campus. That is a proof that you can add on to your maps. You have to find this information about our campus, about our faculty to make the story. And if you look at this map, these two maps, okay, there's no change in terms of vegetation in UM. There is no change from 2017 to 2022. Or there is a change. Okay. All right. So you look, this is the 2017 image, on your right side. And on the left side is your 2022. What happened to this pocket of greens? Do we have a development there? Kan? Something like that lah. But I'm not sure. I think Faculty of Science tak ada changes kot. Just the same lah. All the same. This is just additional info lah. I mean, like if you want to think about it out of the box, what you want to do, what you want to relate with this information, kan? So you can add it to your maps. Okay?
Dr. Nis, can we consider this Sentinel-2 data, the map that you're showing now, itself is our is some of the participants, story map. Can this serve as a story map and then be treated as a legitimate geospatial interpretation? Right?
Yes. Yes. It is. It is. Indeed.
Okay. Thank you. Because we don't want to give the impression everybody must use QGIS and do all the road mapping and so on and building polygons. And eventually that's the way to reach. And some may get exhausted. So as you showed just now, even the elevation point shows some of the topography nature of this place. And one of the points that we try to highlight is the faculty science actually sitting in the valley between the Rimba hill and the APM hill. So the nature of the valley, that's why we have a lot of issue with water bodies, water seeping through buildings and so on. That's an interesting point also some people can explore. And the image that you showed just now is already giving us the data. It's just how strong you want to amplify that message.
Indeed. So this is a vegetation cover in 2017 compared to 2022. Do you see more greens there? So I think we are taking care of our campus quite okay. And of course, in 2017, maybe there's a lot of different weather. Actually, different weather also can give a different interpretation. So from here, we see that some of these areas are actually green areas lah, basically. In UM, this is UM. So if you want to see the land cover or the image, natural color image. Natural color image basically is the satellite image. You cannot see much. But if you already, this is the analytics that have been done, this shortwave infrared, the NDMI, and NDMI actually shows you the water. Yes? Okay? Wetlands, most areas appear blue. Okay? Of course, Rimba Ilmu is wet. Yeah, Prof? And it's the most bluest area there. Okay, like you say, Prof, it can be used. I mean, like, of course, the center of information is Faculty of Science. But if you look it into a more geographic, a bigger geographic areas, you can have more analytics. Or maybe related with Rimba, What do you say, Prof?
Yeah, of course. Connected, geospatial are connected environment. So while we are focusing in one area, in the confluence of various, structure, anyone can come up with. In fact, you can have a stratified, different eagle eye view coming down to a low, elevation, and how much things change to get the big picture into more focused local area. So the story develops and then become more focused, and a certain issue can be highlighted. Because of that, we actually came down from 30,000 feet to 20 to 10, 1,000 feet, eventually 1 kilometer. Then you realize, things are different.
Yes, indeed. Indeed. That's correct. Okay, even from this map, also you can see that Rimba is actually helping to cool us down, give us greeneries. And our campus is actually very, very not so hot lah. I think we can walk around our campus quite okay because a lot of trees are being planted. Okay, more or less, if you want to actually do inventory for the number of trees in your faculty, Prof, you can do that. You can actually take a GPS coordinate of the trees and put it on the map and show that, okay, these are the numbers of trees that you have in Faculty of Science, and you relate to that SDG goals that you wanted to achieve. Betul lah, Prof. Kita dekat belakang apa ni hutan kan, Prof. Yang Faculty of Science is behind, just in front of the forest lah. So it's very, very cool. There, sejuk. Okay, any more question you want to ask related to this, pertaining to any of the data sets or ada tak? Oh, everyone is okay already. Okay, so this one and this one.
The Nis, just to help our participant also in the QGIS, what are the let's say 3 important things that the participant should focus? Just now you highlighted a few, you know, at least the 3 of that sub windows that they must be familiar with. You can suggest that so that they go and find out what does it mean, how the information are extracted and so on. If you can give 3 important lookout for that windows and also the tabs.
Okay. All right. Okay. So in this QGIS, actually the most important thing, because we want to extract data from other sources, we need to have the XYZ tiles. So XYZ tiles, I have actually given in the slides some of the link to the XYZ tiles. Okay, where is it? Okay, so these are the Google Maps style map service link that you can try. You can put in your QGIS. And I will add a few more links for the OSM and also for other. Okay, for like this, yeah, is OSM, Google Maps, Google Satellite, OSM, and also OpenStreetMap. I will give you the link. So that's the same method. No, the same method. You just click here, new connection, put the name, put the URL that I give you later, and then you click OK. And then you double click. It will come down to these layers. You can see the map in layers. Okay, Prof, that's one important thing I forgot to mention. I did mention just now, saying that you must put it on the same coordinate system. Remember, everyone? Okay, I want to show you what is the example of having 2 coordinate system. Okay, this is in WGS 1984. The coordinate is polygon F5, yeah? Look at the properties. So the coordinate system is EPSG 4326, WGS 1984 geographic. Okay, for this one, yeah? For this one. But for the data that we downloaded from the Esri Living Atlas, it is different. It is different. Yeah, it's using zone 48. Zone 48 projected. Okay, so what we need to do is we have to convert it into the same projection. So this one, okay, and this one, zoom to layer, is not on the same page. They are not talking together. Or they are already. Okay, let's close this. So they are here. Okay, I think it is. All right. I think it is on the same coordinate, Prof. Yes, it's on the same coordinate. Okay, no problem. So it's on the same coordinate, so you don't have to do conversion. You don't have to do anything. So you don't have to do anything. But the only thing is UM is here, not here. This is on Malacca side. So you cannot see this data for UM. Okay. One 147. Okay, I take another one. Zone 47. Okay, so we have a complete data set. Both for UM also we have. I will take the polygon on top and put the color to be different. I use just one single symbol. Put it as a color pink so we can see it. Apply. Okay. Where is it? Zoom to layer. So it's over here. So this is the faculty. On the Esri Living Lab. It's very living atlas. So it's actually very, very small. If you want to relate to the surroundings, then you have to take a bigger area. If not, you don't have to use this Esri Living Atlas as the source of information. So the satellite image is basically having the same. They are bigger. They are bigger in terms of the resolution, not like the vector data is very, very small. You can come up to the level of objects on the ground, to the cafeteria, to the walkways and something like that. So for the satellite image, it's very, very limited. Okay, and then when you want to make a map, there is a place that you make maps. Where is it? Huh? Settings, vector, raster. Okay, you have to download a. Okay. Oh yeah. Okay, and then you also have to add. You also have to add this OSM plugin. Okay, this plugin here. There's a plugin here. Manage and install plugin. Okay. So you will have a lot of plugins. Okay. So you need to choose a plugin that you want to be able your data to be seen. So for instance, you just type the OSM plugin. So I already installed the OSM plugin. So when I install the OSM plugin, I can actually easily manipulate the OSM data. Okay, so the OSM tools and something like that, layers plugin, there's a lot of things actually here. And you can look at the, for instance, website of QGIS. They have a lot of information, QGIS information, QGIS tutorial, yeah? QGIS tutorial online for map making. Okay. Of course, there's a video, but if you like to read and see how it's done one by one, you can look at these tutorial tips. Making a map with QGIS, working with attributes, importing data. If you have a number of trees and everything, you can add in that as an attribute inside the QGIS, and downloading and searching OpenStreetMap data. Everything is here. Georeferencing, everything is here. But you just have to look at the QGIS tutorial and find out how it's done. For instance, it will teach you one by one on how to do it. Yeah, and it's very, very not that hard. It's not easy, but it's not that hard. I think everyone can do it. So one by one, and we have tested this. We have tested this tutorial using QGIS, and basically the maps that I've shown you just now from all the students, basically I show them what I've showed you, showed a little bit on how to do it and what is important. Then they managed to build the database. They managed to build the map on themselves. Of course, we have a lot of tutorials, but you can do it. It's very, very simple, not that hard. Yeah. Any more question? Ada soalan lagi, Prof? For the students? Half an hour lagi ya? Okay, so let's try and make a map. You print layout. Okay, Faculty of Science. Okay.
Just now you say we have to convert in the same coordinate, right? But did you where to convert?
Excuse me?
Where to convert? How to convert?
Okay, so if you have different projection, okay, you have to find the projection plugin. Okay. In ArcGIS is very simple. Projection. Projection quick CRS. Okay, the quick CRS. So install plugin. Okay. So the plugin is here. So you choose which plugin you want to use. This is a semi-classification plugin for remote sensing data. Actually, my computer is very, very small. Dia punya text tu tak nampak. Ayo. Okay. Let's say you want to project. Okay. Custom projection, find projection, reproject layers. Let's say we want to reproject a layer. You want to find a map to lines. Let's say just do Faculty of Science. And then the original target CRS is WGS 84. So let's say we want to change it into Kertau. Okay, we want to change it into UTM zone 47. Okay, so we just click run. This is a little bit more technical, but I think most of the data don't need any projection. But if you need, then you need to do the projections. You just find the down here, there's a searching button. You just type what you want to do, and then they will give you some guidance on to do what you want to do. Project wrap, assign projection, extract projection, and so on and so forth. So basically, this is like a help that a live help for you to do it. Or you want to do classification. You want to do a clip. Okay, how to do a clip? So you can do a clip, but for you to do a clip, you need to have a 2 polygon. This is a little bit more technical, but I just close this. I want to show you how to delete some of this data. Yeah, we close everything. Polygon. We close the label. We don't want to see the label. No labels. Okay. Okay. So let's say I off the only this. Okay. So I want to delete some of this data. What I need to do is okay, I want to edit, yeah? I want to edit. Okay. Select. You want to select. There's a selection button now, but my PC is very, very small. I cannot see where is the selection button. Hold on, I find it there for me. Select. Toggle editing. Okay, toggle editing. Okay, so I click. For this one, toggle editing. So you can edit this layer and you can actually open the attribute table. Okay. Open the attribute table. Oh no, sorry. This is the attribute table here. Maybe it's at the back. Okay. So you can delete from here also. Okay, so you can delete on here also. You want to delete maybe air terjun. Okay. You can also delete from here. Or you can delete from, okay, and you see that that is one area that is actually being marked yellow here. Yes? Can you see?
Yes.
So you just click delete and it will delete the area sebenarnya. Mana dia punya delete ya? Actually, I always do in the office because the toolbar is actually bigger, but using my computer, it is smaller because of the resolution. Okay, delete. Okay, so do you see my screen? The QG screen? No?
We see the web page.
Oh, okay. I'm using my another screen. So this screen is actually bigger so that I can manipulate better. Hold on, I will change to that screen. Stop share. Let me share. All right. Okay, now can you see it? Nampak kan? Barulah nampak ada macam-macam. Can you see it? My screen with QGIS?
It's appearing, but so far all black.
Oh. No?
No.
Nampak, Prof?
Yes.
Okay, all right. So, did you see that there's a lot of tools here? A lot of tools here. So you can use it. But of course, when I use my laptop screen, that is very, very small. It's very hard for you to see. So here is open, save. When you roll over the icon, so it will give you information. Print layout. Okay. This one is offset curve for editing and everything. So let's say you want to do toggle editing. Okay, let's say I save it. Right. Polygon of Faculty of Science. I save that. Okay, so I need to remove that. Okay. Just now, I deleted something here. Just now, I deleted something here. The name inside the...
Yeah, you deleted the air terjun.
Yes, I deleted the air terjun. Okay, so let's delete something else. Block D, maybe block D. Okay. Let's delete more. Okay, block D Camellia, where is this? Chemistry, new chemistry, let's delete that one. Okay. So I delete this. Tak nampak lah dia punya ni. Sorry lah Prof, I tak nampak sebab dia punya, bila I change to this bigger PC, there are some things change. So basically if you delete, you can delete everything using a tool that is like a select tool tau. Like tak nampak lah. Okay, dah buang. Kan? Dah pangkat, dah buang. I cut it and it's no longer there. So if you want to cut more, if you want to cut this, you can also cut Ada banyak lah kaedah-kaedah dia. You can cut things. Okay. Alright. So you cut into two already. 2 areas you cut into 2. So all this editing button is useful lah. Basically, you can use this button for manipulating the data, creating the data, deleting or adding the data. But actually what I want to find is the select. So you can select 3 to 4 objects together and delete it, but I cannot find it. So far, I think everyone should have a very general kind of knowledge on the QGIS, betul tak? If you need more information, you can drop me an email. Yeah, I can help you to maybe help you doing finding things for you lah. Maksudnya, maybe if you don't know how to do something, maybe I can help you. Drop me an email or maybe, I'm not sure, Prof, whether they can contact me for consultation ke macam mana?
We can put some links at some queries at the competition website. But one thing that we can encourage is first ask them to explore the QGIS tutorial and try as best. This is part of the learning process as well. And if they get stuck on a very specific issues, then they can put up a notice, send a query, and then we can forward the query to our mentors.
All right. Okay.
So that way we will not be, loading people with a lot of questions and so on. Right? Yeah. We encourage people to explore. It's a part of this competition. Your objective is to learn new digital tools.
Yes.
That's the aim. Yeah.
Okay. So when you finish editing, you save your layer edits. It's good as new lah. All right. I think that's all lah. Ada apa-apa lagi? Any more questions from you guys? If you want to ask me final questions, burning questions.
One question for the student. The file that you need for the competition, is there any specific file extension for the GIS and also the storytelling file, maybe as a .mp4 or something like that, that we need to submit for the competition? Maybe for the Dr. Siti, yeah.
Yeah, for that part, we will update on the website, Dr. Wana, on the format and requirement, because today we also will know what sort of document that participants will be preparing. But the one part that we need is for the panel is to see a maybe if it's QGIS, we'll be able to open the file and see that. And secondly, there will be a presentation as well. So most of the story will come alive when they present. But again, you can have a 3 minutes video that they have to submit explaining their story map. Okay, so we will put up all the detailed information, requirements, submission mode on the website, and how we're going to evaluate the rubric for assessment and so on. Okay.
Okay, thank you.
Thank you.
All right.
I have a question also for Dr. Siti. For the purpose of this competition, in order for us to find a narrative for the storytelling, can I know what is the audience that we're actually addressing? Will this map actually be shown to visitors who are, visiting the faculty, or it is meant for the faculty members like the lecturers and the students?
It is ultimately aimed at to be a public information. So it may be sitting at the faculty's website. That's a heavy thunder here. And it's more like information. So if you go to any website, you have a live digital map. That will be the aim. So the more open, open data communication is the better. Yeah.
Okay, got it. Thank you. One last question from me. I think Vanajan earlier also asked about the border, or I mean the boundary of the map that we are producing. I was going through the map earlier. There are outside of the main complex of the science faculty, there are also some laboratories, but I'm not sure if, for example, the microbiology and genetic lab near the Padang UM. So would that also be counted within the science faculty also? Or we are just looking at the main complex?
The focus area is the primary, the main science complex, not the annexes, so not the buildings that are distributed, because we are looking at the geographic location of this faculty. That is a very exciting area. It's sitting in the valley. Okay. The primary focus. So the narrative, it's better that the narrative represent faculty science in a bigger picture rather than a very isolated buildings and so on. So it is for the faculty of science information. So we would like to, give them a bigger picture, but you can have a story, the narrative covering one or two concrete, aspects. Okay, there's one question about whether postdoc can join this competition. We said that for the students from undergraduate and postgraduates, but postdocs probably can act as a mentor or even as a member. But primary means if out of the 6, we would like to at least 5 students who are undergraduate or postgraduate. We don't differentiate that. Okay. Okay. If there is no other questions, let us thank Dr. Nisfariza for spending time explaining this interesting data visualization platform. And we hope that this session has been helpful. But then again, learning anything, we have to also put our own effort to explore the tutorials and also find out things for ourselves. Then it becomes interesting and memorable. Okay, so with that note, let's thank Dr. Nis all together. You guys can use the reaction button if you know where to find it. We thank Dr. Nis, and also we thank everyone, all the registered participants, and some maybe are planning to register. And we also have some mentors joining us in this session. Thank you, everyone. Look out for updates on the website for Makerspace, this competition website. We will be communicating with you if we have any updates via email, plus a notice on the website. Okay, and some of the queries that you have asked will also be listed as the frequently asked questions. Okay, everyone. I wish you fun exploring this, and as the story builds up, you get excited. We also want to know, the best part of our faculty's, story through this visual science. Okay, have a nice weekend. Thank you, Dr. Nis.
Thank you, Prof. Thank you, everyone.
Thank you. The recording will be uploaded on the competitions, Makerspace website. You can check. And if Dr. Nis would like to share the slides also, we will put it up there for internal sharing. Okay, thank you very much, everyone. Thank you.
Thank you.
Thank you, Doctor.
Thank you.
Thank you, Doctor. Thank you, Prof. Have a nice day.
Thank you.
Thank you.